All right, guys, so this is the last video for the 2018 free response portion of the AP exam. So we just have question 7 to go over. So let's just dive right into it. All right, so right off the bat, we see a PES. If it's the full PES, notice the binding energy is decreasing from left to right. So this is where we start. This is closest to the nucleus. This is further away. And it would be 1s2, 2s2, 2p3. So if this is a neutral element, it's nitrogen. We just figured it out. We got 5 valence electrons right here, 2 here, plus the 3 here. Let's see what they're going to ask. Identify the element. All right, nitrogen. All right. And notice they didn't say like justify or anything, so nitrogen. Or N, you know. Save yourself a little bit of time and just write capital N and you're good to go. All right. It says a radioactive isotope of the element decays with a half-life of 10 minutes. So remember, half-life or radioactive decay is always first-order kinetics. So that means the half-life stays constant. It's always first-order kinetics. And remember, for first-order kinetics, there's an equation on your formula sheet that you can use to calculate half-life if you know the rate constant, or if you know the half-life, like we have here, you could calculate the rate constant. So calculate the value of the rate constant K. Notice this is lowercase k, it's not the equilibrium constant, it's the rate constant, so from unit 7. For the radioactive decay, include units. All right, so we just have to plug our half-life into that equation. So the equation is T1 half equals 0.693 over the rate constant. And this is always works for first order kinetics. And so if you remember that radioactive decay is always first order kinetics, then here. So we're going to plug in 10 minutes here, and we're going to just solve for K. So K equals 0.693 divided by the half-life, which was 10 minutes. And so our K comes out to be 0.069. And the units for, remember, first order kinetics, rate constant is 1 over time, and our unit of time in this case was minutes because our half-life was 10 minutes. So it would be 1 over minutes, or minutes to the negative 1. Okay. All right, and then if 64 atoms of a radioactive isotope are originally present in the sample, what is the expected amount of time that will pass until only one atom of the isotope remains? So half-life question, every 10 minutes, the sample's gotten cut in half. You're starting with 64 atoms and you got to get it down to 1. So, this is where, you could just be sitting there going, all right, 64 divided by 2 is 32. That's 1 half-life. Divided by 2 is, 16. Divided by 2 is 8. Divided by 2 is 4. So 1 half-life, we go 64 to 32. 32 to 16, 16 to 8, 8 to 4, 4 to 2, 2 to 1. So 6 half-lives will occur to go from 64 atoms to 1 atom, and 10 minutes per half-life, so 60 minutes. All right, so that's pretty easy. So let's see. The reaction will have to undergo 6 half-lives to get to 1. So, right, so 1 half raised to the 6th power times 64, that's how we would get to 1, or, again, just keep dividing by 2 until you get there. So 60 minutes. 6 times 10, 6 times the half-life, 60 minutes. All right. And you have to show how you arrived to your answer, so that's the way I kind of did it. You could have 64 divided by 2, divided by 2, divided by 2, divided by 2, until you got to 1, and then done the same thing. Okay? All right. So, that was the AP exam in 2018. So, I wouldn't say not too difficult, but in this one, well, the one thing I did notice about this one as we were going through it was they didn't really give us the molar masses whenever we needed to use them, and a lot of times they do. So I guess it just kind of depends on the year. I expect usually like maybe in questions 1 through 3, they might not give you the molar masses because you have a little bit more time, so they want to, just test to see if you know that, or that's a way they can get you a point, like 1 point if you use the correct molar mass. But remember, a lot of times the molar mass is calculated for you, so when it is given to you, use the one that they give you. Sometimes they round it a little bit differently than what you might get if you use the periodic table. That's number one. But also number two, I want you to notice kind of, I think questions 1 through 3 seemed a little bit more complicated. Or maybe the way they presented it made it more complicated and you had to cut through a little bit more fat to get to what the actual question was. But questions 4 through 7 were pretty straightforward. A lot of them you can just use an equation to answer. You just got to know how to use the equation, where to find it. It's on the formula sheet, right? Ideal gas law, delta G equals negative NF, cell potential, right? All these equations are given to you, knowing that nuclear decay is first order kinetics, and so knowing there's an equation for the half-life there, or in the rate constant. The half-life question was really simple, but it was, number 7 was an easy question. I thought the whole thing, number 7 was. And so that's 4 points, but you're only going to get those 4 points if you get to question 7. So again, it's time management is a big deal. All right. So hopefully that helps. And, keep looking at the different practice tests, keep looking at the videos, and get yourself in that mindset. Attack this test. If you've been working through this course, you have the potential of getting a perfect score on the AP exam. You're probably going to make a mistake here and there, but your goal is to limit as many mistakes as possible. And again, 80%. If you get 80% or better, you got a 5. Sometimes it could be lower than that. Like this year, it could be a 75% or better. It could be a 5. It really just depends on the year. It depends on how hard the test is. It depends on how the rest of the nation does. But, if you get to 80%, you got a 5, right? So you got room in the test to make some errors. And if you're better at multiple choice, the better you do on the multiple choice, the worse you can do on the free response. They're weighted 50-50, right? So if you get a 90 on the multiple choice and an 80 on, or a 70 on the free response, that'll average to an 80, you'll get a 5. Okay, so an 80 and an 80, so that's your goal, right? Get as many points as possible. If you get a perfect score, I'll have to okay this with my wife, but if you get a perfect score, I'll buy you a car. Okay, so they'll write an article about you in scientific journals. Every once in a while, a TJ student will get a perfect score, and they'll write an article because it's really rare to get a perfect score on it. So go for it. You got the potential. All right. Have a great day.